Uh, no worries. We are located in southwestern Oregon, just about 10 miles over the California border and about 30 miles inland of the ocean, Pacific Ocean. So we're in a very wet place. We get a lot of rainfall but we're on a steep climb of rainfall from the coast towards inland, and we keep bees as far inland as Ashland, Oregon, which gets only, say, 18 inches of rain, whereas our home apiaries in the Illinois River Valley get 50 to 70 inches of rain a year. So this is my lovely family who I have the pleasure of working with. Those are Joy and I's three daughters, Tulsi, Sage, and Fern, the oldest there on the right. And why does that keep happening? Okay. Uh, we have our history in running a small operation focused on a diversified suite of bee products, including honey. What's cool about this picture is that there's almost an identical version of this photograph that appeared back in the day in bee culture. Kim Flodham happened to be visiting town and took this photo of us and used it as an opportunity to editorialize on the fact that he wasn't certain whether organic honey actually existed. And we kind of get his sentiment, and complications with certification and the dilution of the quality of the word organic has kind of diminished our interest in certification over the years, but that has rekindled of late with renewed conversations with Demeter, the administrator of biodynamic certification. So a quick plug for the book. We published a new book, which is a summary of our practices and 20 years of experience keeping bees the way we do down in southwestern Oregon. And we do migratory style beekeeping, where we do drive about a day's drive south in the winter time, and we pollinate almonds, and then we're back in Oregon first week of March to spread out and make bee products. So that's a pretty good summary. And one of the impetus of keeping bees at the scale that we do is that we are definitely believers in honey. We just think that more people need to eat more honey. This is our daughter Fern eating some comb honey. We love to produce raw comb honeys, but also we spin quite a lot. And we ran a retail natural food store for 9 years, and we direct marketed all of our product through the store very successfully. It was a really awesome period of time, but we have since moved on to wholesaling, and so we are happy to stock our honey at some really fine locations, including wineries and boutique natural food stores and farm stores, but also at our flagship co-ops and natural food stores in the region. Here is my daughter Sage helping make chunk cut comb honey. So that's all raw natural cut comb produced with foundationless frames and cut and put in, and then extracted spun honey poured on top. This is a picture of actually our first honey crop of the year that we make in Northern California. We do some isolated breeding to start our year in California in a place up in the Sierra foothills, and this is a really wonderful crop of vetch-dominated honey that we produce there. And then we spread into yards that look a lot like this. We tend to put about 24 to 36 colonies in each location, depending on productivity. We try to avoid spots that we can keep less than 24 hives. They're out there. Western Oregon has very dry summers, and so our flows come on strong when the weather warms up in April and May. And then by late July, things are waning down pretty hard, and all this grass right here starts to turn brown. So by mid-August, we're in a dearth, and our honey season tends to be over. In rare years, we'll have a surplus of honey coming in the end of the year in September from field flowers. That never gets extracted, however, it always ends up just backfilling brood nests. So we make a whole line of bee products, several honey products. We make a line of medicines. We also make jun. This is a picture of jun. Jun is a type of kombucha made with green tea and honey instead of black tea and sugar. Also, we make a whole suite of different recipes. Joy is our principal brewer in the operation, and she produces most of it into 5-gallon kegs, which we distribute to restaurants, bars, and food stores. But we also, like I said, make a line of medicines. These are tinctures that we make, and the menstruum is a mixture of honey and apple cider vinegar. So these are a whole line of alcohol-free tinctures that we make. And then we will also make a very high alcohol tincture of propolis. And we sell about 8 to 10 gallons of propolis tincture in 1-ounce bottles a year. So that it amounts to a significant portion of our income distribution. And we hand harvest all of our propolis from paint-free equipment. That was part of the reason we moved to manufacturing all of our own equipment and getting off of latex paint, which I'll show you a little bit here. So another one of the value-added products we make is woodenware. So we make a line of 8-frame Langstroth equipment in all mediums, or what we call out here a Western shallow, 6 5/8 inch box, though we actually make our boxes 6 3/4, giving ourselves a little bit more room over the top bars. So this is what our operation looks like. As you can see, we're palletized. We move our bees with a forklift. We spent a long time moving bees without a forklift when we were young, and maybe, I don't know if you want to call us idealistic or or maybe misaligned. I don't know. Anyway, we are happy to produce our own equipment. One of the reasons why is because we add a lot of bells and whistles to our equipment, and we make it exactly how we like it, with a bunch of features that are described in our book. But the other reason we really like making our own equipment is that we get to be responsible for where the lumber comes from. And so this is a standing dead cedar tree that we purchased off of a neighbor when the highway right-of-way crew took it down because it was dead. And we bought it, and it's incense cedar, and one of our favorite woods to make hives out of. We also make our equipment out of redwood quite a lot. So this is what our wood shop looks like. A fairly humble operation. There's, less than $20,000 worth of equipment in the room. And honestly, you could do what we do for less than half that. If you wanted to forego like the 12-inch joiner that's at the center of the room there, that's an expensive item. And you could also go with a much less expensive of a planer than we use. And if you did that, you could do what we do for really just thousands of dollars in a home shop. So all of our assembly, or the details, the specs of our equipment, are also shown in our book if someone is curious. This is a stack of the migratory lids that we produce. Simple 2-piece lid, minimal seals, and the redwood really makes a superior quality hive. We love so many things about our bee hives, but really one of the favorite things about them is the growth form of the wood is closed cell. So inside of redwood and cedar are little tiny air pockets from like the vacated cell contents, the inside each cell, and that structure is maintained. So basically the wood is like bubble wrap, which gives it our value. And so our beehives are not only warm and cozy and dry for our bees in the wintertime, which is a real issue, as I mentioned, our high rainfall, but our beehives are actually also cooler because the insulative quality of the wood doesn't take on the solar radiation of the sun quite so much. So overall, they're just an easy hive for bees to inhabit, and they seem to really thrive in them. This is a picture of us applying our hot dip. We hot dip our equipment with a homemade mixture of linseed oil that we boil, raw linseed oil that we boil ourselves, and then we add beeswax and pine rosin, and then we heat it and dip. It causes the sealant to penetrate nicely into the wood, but the consistency of the the finish is more like a varnish, so it forms kind of a nice sealed skin over the outside of the equipment. And that combined with the rot resistance of the wood that we use makes it last a very long time. Almost all of the boxes that we first started building, oh, I don't know, it's been about 10 years since we started manufacturing our equipment. I can't remember exactly, but we haven't disposed of a box from rot yet. So
You dip the brush?
sorry, say that one more time.
You dip it? Or
Yeah,
you make-
we dip the exterior surfaces. So we leave the interior unfinished, but we dip all the exterior surfaces. And you can see here in this picture, the equipment to the far left is our equipment that's been dipped. That hive in the middle is a Warre hive and has not been dipped, you can see. So these are 3 hives that sit in my front yard, and I use them as a teaching tool for having groups come through, and we look at these hives. And what they're here to demonstrate is complexity of hive construction versus function. So obviously on the far right here, we have a hollow log hive that has very simple construction, if you will. However, this log hive is a little nicer than your average log hive because it actually splits in 2 rather perfectly. So I actually can open this hive and I can inspect a little bit and see brood, confirm the presence of a queen and what have you. But obviously anything beyond the most timid of exploration, and I'm going to start destroying combs. And indeed, in this colony are combs laying on the floor of the hive that have dislodged from the walls of the colony in previous inspections. And so you kind of get to, when you inspect this colony, you get to kind of see the drawbacks of the simplicity of this hive design, if you will. It's difficult to do anything like extract bee products without being fairly destructive. So then likewise, in that progression, we move to a Warre hive in the middle where you now have a box hive that is a little easier to separate, but these boxes have only top bars in them and essentially often produce combs that are very difficult to handle or inspect. And again, you're kind of limited on your ability to look in on disease or mite presence or the quality of the queen. And you're sort of left in this black box style of beekeeping a little bit. But then what all these 3 hives have in common is that all 3 of them have a brood nest that is manufactured solely by the honeybee. So in the boxes on the far left, our natural nest style equipment that we manufacture are brood frames that are foundationless and actually have no bottom bar on the bottom of the brood frames, allowing the bees to grow their nest in a downward direction and thereby create a brood nest of their own liking that is uninterrupted by any frame parts. And that is a requirement of natural nest of biodynamic beekeeping standards. And so the natural nest hive on the right having kind of the highest function, it's a framed hive, it's a movable framed hive, but it's also meeting those requirements of biodynamics for a foundationless colony brood nest that's totally organized by the honeybees as regarding cell size, production of drone comb, etc. So here you see, this is a foundationless hive, foundationless frame out of a hive that is actually kind of the predecessor to the Western shallow style beekeeping that we do now. This was our first experiment at foundationless brood nests, and we ran a couple hundred colonies like this for a bunch of years, where we had a frame that was actually about a 15.5-inch deep comb, and that enabled again the bees to have a completely natural brood nest of their own making. These hives we discontinued using, however, because they were really difficult to grow colonies in. They were fairly nice for established colonies to occupy, but making divides and getting small colonies to fill out these huge cavities, we found was just sort of counterintuitive to the bees, like thermodynamics, and the bees moved really sluggishly in them, and that was what led us to changing the way we do things and working towards having a style of beekeeping where the cavity size is adjustable and increased in minimal increments. Here's my daughter Sage, who you actually saw in the picture in the kitchen. So this is an old photo from a style of keeping that we no longer do. And now we have moved along to something that basically looks like this. So we're growing out new brood frames like this, and then they grow to something that looks like this. And then this hive here is now ready for nadiring. See, you have a completely stuffed out hive. And if you look carefully, that's actually an 8-frame hive. And the piece of wood you see on the far left is actually a division board that is just stored in a slot in our equipment. We have just like a storage slot in our equipment for storing a division board. But then that division board can be removed and inserted in the middle. More on that later. But then once the hive is fully filled out, you can nadir it, aka you can take an empty cavity and place it below the brood nest, allowing the bees to draw out their brood nest in a downward direction. And you can see that that's what this colony here has begun. This is a picture I took this spring, and you can see I had just perhaps a week or two beforehand gave this colony an empty box below the brood nest. And now you can see all that new lighter brown colored brood on the left has been made on new comb as the colony is expanding their brood nest in a downward direction. And this is a photo to show that it doesn't always go perfect. And managing foundationless beehives is a trick, and it needs to be monitored, and it's going to require you to make manipulations of combs and of the colony in order to fix messes that you find like this. It can also result in a colony that's not fully inspectable. If you want to be lazy about things, you can let combs like this go crazy and just leave it to the fact that you can only inspect part of the colony. I don't really tend to enjoy that, so I tend to cut combs and refasten them between the end bars of the right frame and help the bees back into a movable frame configuration where I can move combs and inspect colonies. So our operation is perpetuated by the in-house production of our own new queens and new starter colonies. And we have been running a closed breeding program for 8 years now. And that means no introduced queens, no outside source of matrilineal genetics. Of course, we're always mating our bees in fairly isolated yards, but open mating. And so there's undoubtedly an exchange between our feral population, but we are fortunate to raise our new colonies in the absence of other commercial operations, which is important to some of the breeding work that we're doing. This picture here is, you may see a queen excluder sticking out of between two boxes. That's a 10-frame excluder on 8-frame equipment. And we actually don't mind that. We use 10-frame excluders in the preparation of our walkaway splits so that we can walk through a yard and really rapidly, easily spot them. So it's kind of nice when they stick out like that, especially when we come back to pull these walkaway splits often at dusk or even in the dark. And having these little excluders sticking out the side is of benefit. So above the excluder is a colony that has been set up with a divider, two-way, and made up as 2 4-frame nucleus colonies with everything they need to raise a new queen. And now I'll see, here is a photo of that. So you see the division board down the middle, and then all of our equipment is set up with two-way compatibility. So underneath that box is a two-way bottom board that has an entrance at each end, allowing those two four-frame starter units to be isolated from each other and have entrances at the opposite end of the box. So what we've set up here is two four-frame units that are both given the opportunity to rear a new queen. And for us, that process is 65 to 70% successful on average. And thus, when we come back and inspect these 1 month later, the most common result you're going to find is that one starter colony succeeded and one failed. And in that instance, we're going to pull that division board and we're going to reunite those colonies. And since they're half sisters, since they know each other all, the process goes really nicely. One side is queenless and has a low morale. And so you never see fighting. And within a day or so, that queen is laying throughout the whole box. So here is a picture you can see of some emergency cells being started. This is a colony that was recently split off from its parent colony, and the bees have come in and selected a few egg frames, or sorry, cells with eggs to start rearing cells. And you can see there's maybe 3 or 4 open queen cells there. And we often produce really large, really nicely worked cells like this. And this is a picture just to sort of help talk about this notion of emergency queens. People have a stigma about emergency queens, and I'm here to break that. What I think people are used to seeing when they see emergency queens is that they're used to seeing a hive that was demoralized, perhaps that had already ran into a fairly broodless state or had a messed up demography of age distribution in the worker bees, maybe older bees that had to be recruited back into the development of their hypopharyngeal glands and what have you. And so you have bees that maybe are lacking the appropriate nutrition and the right cast of bees for the rearing of a good queen. And that oftentimes results in an inferior queen. And so when we rear our queens, we're out to do the opposite. And we're out to make sure that each of those 4-frame units there are absolutely packed out with bees, can't fit another bee in there, have a full frame of pollen, a full frame of honey, and a copious amount of young bees and young open brood to select from. And when we put bees in that condition, we are stimulating both the impulses associated with queenlessness, but we're also stimulating the impulses associated with swarming. And that is how you produce a quality queen cell, is by having a congested environment where there is a copious amount of young bees and forage coming in, and that leads to jelly-rich large cells. The other ingredient, of course, for great queens is drones. So this is a foundationless frame full of drone brood. We get a lot of drone brood produced in our hives because of the foundationless state of a lot of our brood nests. And so we move a lot of drone brood like this into our mating nukes. So aside from the fact that we place a lot of drone colonies, drone source colonies, we also send a lot of drone brood along in our mating nuclei, and thereby increase the diversity and abundance of drones in our mating yards. This is what one of our mating yards looks like. You can see in the foreground are supered drone source colonies, and in the background are two-way mating nucleus colonies. And we'll produce 300 to 500 queens a year, like using this method, or sometimes more, but typically. This is our main mating yard in Oregon. You can see this is getting near the end of the growing season, probably late July. Here's another shot from California with that vetch flow. Really fun place to work. So we are accustomed to seeing brood patterns like this in our mating nucleus colonies, and that is a testimony to the fact that we are producing quality queens. I have also, I'm just out to share with people, there is good science where people have reared queens in different circumstances, aka grafted queens, queens produced via swarm cells, and queens produced via emergency cells made from eggs that were intended to be workers. And then they've taken those queens and submitted them to like the Harbo lab on the East Coast, where they test them for the weight of the spermatheca and the number of viable sperm, and they have shown emergency queens to compare very favorably or even exceed the quality that you might find in a grafted queen. So that data does help corroborate and help us feel good about the way that we raise our bees. Another cool thing about what we do in our operation is that we attempt to raise new daughter colonies from every living extant colony in our operation. What we're trying to do is basically run a soft bond style operation where we use minimal amount of intervention with regards to mites or disease suppression or anything like that. And pair that with the retention of the maximum amount of genetic diversity that we can, aka never intentionally excluding bees from the breeding program, and essentially letting vigor and hardiness be the only selection criteria in our operation for what bees get reproduced. So what we're experiencing is a gentle selection criteria, basically based on vigor, meaning if a colony is very vigorous, it will get maybe as many as 6 daughter colonies reared from it. And if it is showing overt signs of disease or something, then it will get 0 colonies reared from it. But essentially, if it's not showing overt signs of disease, we will attempt to raise starter colonies from every colony. And in that way, we're kind of hoping to allow traits associated with Varroa resistance and other traits that we're interested in, principally queen longevity, to stabilize in our operation without creating a genetic bottleneck. And so there are,
Has anything to do with gentlemen?
Are
Sorry.
we have a question about, as you continue to, to rear the vigorous colonies, how gentle are they?
Well, I will say we do not select for docility. That's not something I'm really interested in. However, I'm happy to say that our bees have not shown any real drift towards a wild type like lack of handleability. I prefer working with a smoker, though I often do not. And I get away with working without a smoker, without adequate protection when the weather is nice, with no problems at all. Of course, as a commercial beekeeper working in large commercial apiaries, 20, 30, 40, 60, 80, 100 hives in a yard, I prefer to use a smoker and minimize like the often inevitable increase in alarm pheromone in the air over a day's work, so but a little bit of smoke and I feel like these bees are kittens. So it hasn't proven an issue for us yet. I on rare occasions have pinched a queen for excessive hostility, but I really try not to. And what I find is that that's not a trait that's always associated with the genes of the queen. And there's an interesting, it's a topic that we could talk about if there's time at the end or something. But drones and the semen of drones and the behavior of drones and the mother of a drone have a very large influence over the behavior of a colony. And oftentimes it's a particular patriline of a colony that will cause the cascade of the eliciting of defensive response. And thus a defensive colony may not really necessarily need removed from a breeding program. And this is something that I've had to give a lot more thought to and was brought to my attention by somebody smarter than me not too long ago. Anyway, what we are seeing, which is sort of a testimony to the fact that we are developing over time into an inbred line that is in a kind of a nice, thorough genetic exchange with our feral population, is the changing of queen coloration. when we got started in beekeeping, we quickly moved to using the New World Carniolan as our basis for our operation. And for many, many years, only bought New World Carniolan queens, which were almost exclusively all black. And then once we were established with NWCs for a number of years, we started working with a local queen breeder from Old Soul Apiaries, John Jacob, who runs an operation focused on survivor stock about 50 miles as the crow flies from our operation. So he was really the natural partner to work with in terms of locally adapted genetics, and he was working with bringing in all kinds of awesome lines of bees, including Russian, SMR, VSH, and Caucasian lines. And so for many, many years, our queens looked exclusively like this one pictured here. What's neat is that that queen and this queen here are actually half sisters. I know because I took these pictures. And this queen here is exhibiting what we now find to be the dominant color morph of our operation. And this kind of Italian wild type coloration is genetically dominant. And so what we're seeing is that there's definitely some evidence of some drift, if you will, in our population, in our what I like to call meta population as our operation. And we're finding more and more queens now look like this, which is sort of interesting because we haven't bought an Italian queen in 20 years. So, but this now is what most of our queens look like here. So we recently are starting to ask, okay, what are we doing? Is the work that we're doing having any success? And we had the opportunity through our consortium, the Adaptive Breed Breeders Alliance, to tap into some new technology developed by Kyra Wagoner over on the East Coast. She developed a very sensitive test for hygienic behavior called unhealthy brood odor. And we were able to get some of that unhealthy brood odor this year and use it to test the hygienic behavior of our bees. Unhealthy brood odor test is thought to be maybe an order of magnitude more sensitive than the freeze-killed brood assay that many of you are probably familiar with. Essentially, unhealthy brood odor is a concoction of compounds that have been identified in sick brood, and then they have been synthesized, amplified and synthesized. And then what you do is you spray them on a group of capped brood like you see here, and then you place them back in the hive for 2 hours to see if the bees respond to those chemicals. And this is an example of a high level of response, and something that you wouldn't expect to find more than maybe 1 out of every 200 colonies in like an unselected population. And so we weren't expecting necessarily to see this, but we did do 29 tests, and we were happy to find that we found 3 colonies that had a high level of hygienic response to unhealthy brood odor. You can see colonies 3, 12, and 26 had a high level of uncapping after 2 hours. And so while it's dangerous to extrapolate, we could guess that maybe as much as 10% of our operation are expressing a high level of hygienic behavior, despite the fact that we're not actually using any selection criteria to try to stabilize those traits in our operation, aside from minimal Varroa intervention. So where are we headed from here? The answer to that is that we're finally moving into a program. We're working with some data management specialists to start something that we tried to do a long time ago and quickly realized it was more involved and complicated than we were prepared to handle. But we're going to start this year at colony level tracking of lineage. So we're going to start a tracking pedigree, tracking the parentage of every colony in the operation. And that way we'll ultimately be able to start producing kind of population-wide family trees that encompass the whole operation, the whole population. And by doing so, we can start asking the question with various types of genetic testing about things like the stabilization of genetic traits and also the the heritability of certain traits such as queen longevity. So that's something that we're particularly interested in, is to start documenting the longevity of queens and then to see if we could create an environment where we can document the inheritance of longevity and development of lines of bees that actually have the propensity for long-lived queens. So that's sort of what we're looking at. And then, of course, we want to take the time to compare the genetic variation within our operation and compare it to our feral population that we are operating in proximity to, but then also compare it to, say, the variation that you would find in mainstream commercial operations that are, say, dependent upon grafted queens that may be coming from like a lot more of a bottlenecked background population of bees. And so this is a picture I took down in California last spring. These are our hives triple stacked, ready to go onto a semi. Like I said, we do almond pollination every spring. And then we end up back in Oregon. This is a picture from my home yard. These are bees that actually got vacated from the coast right before it got muddy at the end of the year here. And I operate in bear country. This one is was a sad one from this year, and I'm afraid maybe one of my biggest losses ever. I think I got about 6 or 7 colonies out of there. So I've lost almost 20. And about half of our operations are behind fairly sophisticated bear fences. And obviously, I will never keep bees here again without another one. And it's just a big expense of ours. We have to put hundreds of dollars a yard into fencing and fence chargers and what have you. But obviously, that's less expensive than this. Here we are getting out of the mud. This is what my day looks like sometimes as a commercial beekeeper. Those are forklift tracks. And the farm that I picked these bees up from were probably a tiny bit annoyed with me. But it's walking that walk of trying to leave your bees in good locations. This is a very productive spot with a lot of late nectar and pollen. And so by leaving these bees into the fall weather a little bit, they probably built up really strong. But realistically, I probably should have gotten them out of there about 2 storms sooner. So live and learn. This is another shot of foundationless honey, one of my favorite things to produce. And of course, frames like that can get used to grow out foundationless brood nests and new starter colonies in the fashion we like. And these are my lovely co-workmates that you got to see at the start. That's Sage on the left and Fern on the right. And that is where I will stop. I think I did a pretty good job of leaving some time for a few questions.
Wonderful. Does anyone? Is there
Let's-
anything on
There's
mine?
nothing in chat.
Okay.
Oh, okay. I can't see
Yeah.
the chat when I'm in the full screen share.
Yes.
It's okay, we have people live here in the meeting too, so we'll.
Oh, there we go. There we go. Great.
He's
You know.
talking about the different colors that seem to be on these bees. Is he noticing certain behavioral traits or traits that he appreciates? He sees a white one. This is, oh, good, this is gonna be a good one to watch.
So we have a question about the genetic drift in your queen bees.
Mhm.
and how you've noticed that they're changing, right? Their physical attributes are changing. They're a different color. Are you noticing a pattern between certain attributes and the color of the queen?
Well, that's a great question, of course. I mean, I think there are attributes that are associated with queen coloration. They're not perfectly correlated or anything, but have always had the impression that darker colored bees are often some of the coldest flying bees. They tend to have traits similar to carniolans, where they have smaller brood nests. They have a more rapid expansion in spring. They fly in colder weather, and they tend to be more defensive. So those are all characteristics that I think still hold true in our operation for dark versus light colored bees. What I don't think is necessarily true is that light coloration is associated with some of the like there was Italian characteristics that I really haven't personally experienced in very long time, because we learned right away that we didn't want to keep Italian bees, because we as we talk about in the book, just experienced Italian bees growing really large brood nests, consuming huge amounts of stores, and basically just being like giant Varroa factories. And I don't experience those characteristics in our operation anymore. So I don't really think, excuse me, that coloration is true of the light colored bees, but or or those kind of classic characteristics. I don't see those characteristics holding up with our bees necessarily. So, so the answer is, the vote is out on that one a little bit. Yeah. I will say, while I'm talking, if someone else is formulating a question, I'd be happy to take it. But there was a question up early on about our equipment, and talking about, I think, the square inches associated with an entrance. There was a quick request for just touching base on that. Yeah, so our beehives really only have um, like total square inches of maybe 5 or 6 square inches in total entrance opening. And we like that. Back when we started keeping bees, kind of the classic bottom board, probably had almost maybe 10 square inches of opening. You had like a 3/4 inch high by you know, uh, 14 inches wide. And that was an entrance that was designed for the use of an entrance excluder, and basically often would result in a too large of an entrance, either in fall to prevent robbing, or in winter to keep out inclement weather. You kind of were obligated to use a queen excluder. And so we don't use queen excluder, or sorry, I don't mean entrance reducer. Sorry, I didn't mean queen excluders. Oh my goodness. An entrance reducer. So a big entrance like that I was talking about, 3/4 by 14, is almost designed for the use of an entrance reducer. And if you're not using an entrance reducer, you're exposing the bees to a lot of stress in the late summer and fall. So we don't use entrance reducers on the equipment that we manufacture now. They only have a 3/8 inch high entrance, which is a little below average, but we find that it provides the bees plenty of room, even with a nice nectar flow on for the coming and going. It doesn't result in congestion at the entrance in the middle of summer, but also leaves the bees with a very defendable space, and still adequate amount of air flow if they want to be moving air in and out. And then, of course, on that note of entrance size, is sort of deeply related with entrance position. And our two-way equipment has a really powerful effect by having our two-way bottom boards. There is an entrance at either end, and for a full-size colony that's using the full 8-frame width of the box and not a division board in the middle, that means that they have an entrance that's essentially on one side in the sun and on the other side in the shade, almost always at any time of the day. And And because of that, the bees are very differential in their use of those different entrances at different times of the day. And it becomes this really powerful tool that you're enabling the bees with, where all of a sudden it takes them way less bees to shut down a sunny entrance in the middle of a hot day. And then they can do so and completely close down that entrance and use this entrance that's in full shade. And that becomes the busiest place of activity in the middle of a sunny day. Whereas the entrance on the front side oftentimes gets the morning sun, or, depending on the positioning of the pallet, of course, it can be backwards, but by having two entrances, it gives the bees a lot of power and control over the air that comes into the hive and the access they have to the weather. So, yeah, that said,
Hey, Eric,
go ahead.
sorry, Eric, this is Walt. In the book, you mentioned you put your hive entrance 7 inches from the ground.
Yes. Okay.
What max do you have that you had?
Yes, no, that was what you were talking about before. I see. Well, my answer to that is that, yes, I like that height. If I was to optimize that, I might come up another few inches. I think for the bees' sake, it can maybe be beneficial if I was to say set my pallets down on another pallet that got them another 3 inches or so off the ground. That would be ideal. You can't really go much above that before you solve the problem of dew and you solve the problem of too much moisture getting into the hive at the bottom, but you get up into an increased amount of drafts and tippiness. And then, of course, you also get the problem that the colonies start to get tall. And so then all of a sudden, if you're working a tall colony that's already a little bit high off the ground, then all of a sudden you're like having to take a box off to get a good look down inside, or you're, definitely making it hard on your back to work the bees. So I really like my top supers to come in about breast height so that they can be removed without any real, heroic efforts. And so I will often set my pallets down on a single pallet, and I like that, but also just by being about, if I'm just on my one pallet, then with the bottom board, they're almost, around 6 inches or so off the ground. And I like that. The running of the redwood really helps with hive moisture issues. We just, the interior of our hives stay really dry because the wood will not absorb the respiratory gases or the gases like from ambient. So if there's a little bit of water getting into the bottom board because of weather, which our cleats really do act as a nice little awning and keep most of the water out of the bottom boards, but every once in a while you're going to get a little bit of water getting into a bottom board. The good news is that the closed cell growth formation of the wood that we use prevents any absorption of that water into the walls of the hive. So we just never find mold problems, and we never find like dank, wet corners to the interior of our hives because of the equipment. And that 8-frame format really helps with that too. The bees occupy the space really naturally.
All right, we have another question. For beekeepers that only decap the comb and leave the drawn comb for the next year, how many years can you do that without the honeycomb becoming too inflexible to be reshaped if needed for a drone or queen cup?
Wow. I don't think that I think bees can make queen cells on any old comb that you want. Now, I mean, normally bees aren't going to make a queen cell unless there's some kind of a flow, unless they become queenless in the middle of the winter. But even then, I have seen bees draw out queen cells in the middle of the winter on very old combs, and you get these very, dark colored cells made from very old comb. But I don't have any reason to believe that the bees can't do that if they want to.
All right,
Yeah.
great. Ashley, did you want to?
There was a section of your book that mentioned putting hives in almost barren landscapes, and it helped regenerate the land. can you talk about that briefly? I thought that was so interesting.
Yeah, this is a topic, thank you for bringing it up. It's a topic that I'm personally super fascinated with and I'm very, very familiar with. And one of the reasons is that I live in an area that has a lot of gold mining scars. So I've had the opportunity, and I live in a place that has this very interesting soil that is known as serpentine. It's a peridotite soil that comes from the breakdown of serpentine rock that is very, very high in magnesium and thus very relatively low in calcium. And because of that, most plants do not grow on it very easily. And there's an evolved flora that grows on it here, which is one of the reasons why we have such a diverse plant community in Southern Oregon. But aside from that, aside from that specialty evolved flora, normal plants won't grow on it very well. So when people came along and hydraulic mined out the bottom of all the drainages where I live, it resulted in these tailings and soil types that were devoid of vegetation for over 100 years. So I had the pleasure of occupying a place like that. And I've also had the pleasure of occupying overgrazed, kind of trashed out farmland that was never properly cared for and had its topsoil diminished into virtually zero. And so those opportunities of keeping bees in these damaged landscapes, it's been nothing short of jaw-dropping to see how fast honeybees accelerate the evolution of soil communities. And literally by jump starting the nutrient profile of the soil just causes the plant community to take off from nothing. And a lot of times on really rocky ground, there will be these warrior plant species, members of the Brassicaceae and Rosaceae and what have you, that will grow on these barren rock ground. And then within a year or two of being colonized by these colonizer plants, you'll see grass coming in. And within a few years of that, you just see the grass get thick to the point where you see soil development and you see like topsoil. It's absolutely amazing how fast the bees stimulate this process. And it's really obvious that the bees are behind it. You see like in a perfect gradient and in distance from the hives, how lush and thick the plant communities will grow back on these rocky, impoverished ground. In fact, it's becomes a subject of research interest to other people, but Joy, my partner who can't be here tonight, she is in fact starting a research project with Southern Oregon University where they're going to start documenting this, and they're going to look at changes in soil nutrient availability, pH, carbon, fixed carbon, and soil microbiology with the presence of beehives. So they're going to start placing hives out and then measuring pre and post soil community characteristics. So stay tuned.
Does that, I'm sorry. I was gonna ask you, does that process affect the honey flow? You still get a lot of honey with those hives that are in the barren areas?
So the question was, in the hives that you have placed in highly disturbed or barren landscapes, do you still collect a lot of honey?
Yes, that's a very good question. Just to be clear, as a beekeeper, I'm never interested in putting bees in a place that is barren on the macro scale. I do know of locations in the valley that I live where the forage is too low that I'm not interested in keeping bees there. So to be clear, I never put bees in places that on the whole are impoverished. On the whole, I make sure that my apiaries are in proximity to an abundance of intact native plant communities. I will say though, I've never documented any kind of a noticeable change in yield, but I do have very good anecdotal evidence of a change in plant communities. I have witnessed myself as a botanist, I'm fairly sensitive to the composition of plant communities, and I have witnessed the development of plant communities over time in places where there used to be fewer plants that made flowers. And so I've definitely witnessed the honeybees' role in increasing the richness and diversity of flowering plants on the landscape. When they pollinate plant communities in a good way, that sets the stage for increased seed set and increased like resource acquisition, resource deposition into floral productivity in perennials and stuff. So when honeybees pollinate the landscape, they make more flowers downstream, and that becomes a perpetual thing that results in an ever increasing number of flowers, obviously to some kind of limit that I'm not aware of.
Okay, we have some questions online. Can I jump to these and we'll come back in here? Is that all right? Okay. One person asked, how do your foundationless frames impact production?
How do foundationless frames impact production? Is that the question?
Yes, is it harder, he says?
Yeah, yes, it is.
Yeah.
Yes, it is. If you read, for instance, books about Warre style beekeeping, they will suggest that like Warre style beekeeping with not only foundationless frames, but also a lack of supering is likely to produce like less than half as much honey as say a commercially managed hive with foundation. So you are going to take a productivity hit when you work with foundationless colonies. That said, I still super with hives with foundation, with boxes with foundation. So I can have a yield fairly similar. And so my life with bees, foundationless versus foundation containing is fairly similar in that most all of the first year colonies that I establish with a brood nest, whether it has foundation or not, will not produce a surplus honey crop for me in Oregon in their first year. And then they need to successfully winter before I'm going to succeed in producing a surplus honey crop from them. And that's true with either. So yeah, I live in about the worst honey producing region in the nation. But what we lack in quantity, we make up for in quality, I like to say.
Okay, thank you. There's another question. As you transport your bees to and from other areas, do you notice any increase or decrease in mite counts?
That's a great question. I would guess that I would guess that I am subject to ingression of mites into my bee operation. Am I visible? Can you see me now?
Yeah.
Okay, good.
Yes.
I would guess that I would guess that I receive ingression of mites into my operation in California in the month of February when I am pollinating almonds and there are other honeybee operations in proximity to mine. I have the good fortune that most all of the almond ground near me is managed by pollinators that I know from Southern Oregon, and we work together, but that's not 100% true. There are a couple California beekeepers that keep bees near me down in California as well. And so I would guess that that is where a lot of my mites come from. That said, I'm not totally upset with that. What people need to understand is that I'm not actually trying to get rid of mites in my operation. And what I'm actually trying to do is to maintain mite pressure and help the bees out as little as I can to keep the roof from caving in. So what that used to look like for me is about 40% annual losses in the winter. I'm getting to the point where I'm down around 20% annual losses. And I think some of that has to do with better bees. I'm sure better management too, but better bees. And and so in a way, I'm okay with receiving more mites while I'm in California. And then obviously, once I spread out to, most of my honey yards are fairly isolated. And so I would guess that my mite count just sort of kind of goes down from there once I leave California. How's that for an answer?
And one last one from online. Since queens and drones have different flight paths, do you have another yard a mile or two away so that the bees from the different yards are meeting with one another?
That is a great question. And the answer is sometimes. I have in California, I do my best with good isolation. And then I have 2 yards there that are slightly under a half a mile from each other. And that's as good as I can do. And so there I leave a lot of drone source colonies. In Oregon, I got it covered really good. The picture I showed of my mating yard in Oregon, that yard is pretty much in the center of the upper part of the valley that I live in. And I have yards in basically every direction, 1 and probably 2 miles away. So that yard, I have a feeling I'm getting fairly high drone saturation. One cool thing actually that we're going to do this year, since you brought the topic up, we're having someone out to our mating yards, and we're going to use unmanned flying drones, the other kind of drones, to search for drone congregation areas. And the person who specializes in doing that is named Julia Mahood, and you could have her come give your club a talk on that sometimes. But she specializes in finding DCAs, and it would be really exciting to know about where my DCAs are, and ultimately then kind of that's going to open up the gateway to new levels of DCA research, like getting at the question that you just asked. Whose drones are in the DCAs? Are they my drones? Are they someone else's drones? Am I doing a good job of having enough drones there? You know, we compare the semen composition of queens that are mating in those DCAs to my drones and see how similar they are, things like that. So anyway, that's a good question, and I'm doing my best to attend to it.
Thank you. Okay, back to the classroom. Back here at the back, yeah.
Her name was
Julia Mahood, and she is, darn, I could tell you what state she's from usually, but I know her. She's
Is it Georgia?
I think it is.
Yeah.
I think so. I actually have her bio on my phone because we're arranging.
Yeah. We had her as a speaker here before one time.
Oh, okay,
Yeah.
cool.
Okay, yes.
You haven't made any mention that I heard as far as, you know, oxalic acid or other kind of treatments for controlling your mites on there. Do you use that, or your hive strong enough? You have a pretty good carryover without needing to.
No, I'm definitely not treatment free, to be clear. And that is the soft bond reference that I made, meaning that we are about gosh, we're probably 8 years oxalic only. We've been using only organic mite varroa control since we started keeping bees 20 some years ago. But we've been oxalic only. I've tried all of the commercially available treatments. I made my own treatments for a long time from formic and oxalic and thymol. And I kind of got tired of damaging queens and open brood. And I finally just settled on oxalic acid because it was the only thing that was gentle enough that I knew I wasn't going to hurt my bees. So that said, it oftentimes can be ineffective if you're not using it right. But again, as I mentioned earlier, I'm kind of okay with walking that line of minimal mite control. So I do use oxalic, but what I like to explain to people is I think the single biggest thing that affected the success of our operation and keeps our losses under control is not the use of oxalic acid, but the use of the walkaway split as a management control used in our spring. So why the walkaway split is so powerful is that when I make my walkaway splits, I target the capped brood in the hives and I target the oldest capped brood. And you can tell a difference between the age of brood if you're paying attention. And by targeting the oldest capped brood, I am pretty effective at removing huge quantities of Varroa from my colonies when I make these divides. These divides are then queenless for 30 days. And they basically will go through a nice prolonged brood break and shed almost all of the mites that leave in them. So by doing 2 rounds of that in the springtime, I pull a lot of mites to Nowhereville out of my operation and stabilize the mite population in my hives, which allows me to basically do a single mite treatment in the summer. So
As a follow-up, are you using the vapor or the sponge?
I'm using sponge. I personally don't believe vapor is worth doing. And there is science that shows it's effective if you do it all the time. And honestly, I don't choose to wear a respirator.
Any other questions?
Mites is what I want.
So, you make your own sponges?
I do. As per scientificbeekeeping.com.
Do glycol, oxalic acid?
Glycerin.
Listen,
Yeah.
that.
Food quality sponges. Food quality sponges.
Sorry.
Where do you get your sponges from? Are you using?
I have honestly, I've had very good years the last few years, and so I just don't deviate. I spend the money on If You Care, and they are expensive, but I don't choose. They're worth a living bee colony, and I'm having really I'd love to chalk it up to that hygienic behavior stabilizing, but I think that If You Care sponges work really well.
Can you spell that? If you care?
It's a brand name. It's a brand name called If You Care, and they're a manufacturer of cellulose sponges. You can get others out there too. And I've had generic ones offered to me, but I'm just phobic.
So Jerry Lynn printed off some information from, is it the American Bee Journal? Yeah, and so if you want more information about sponges and materials, Jerry's got a handout, and if we have time, we can talk about it.
Yeah, and scientificbeekeeping.com, highly recommend that.
Absolutely.
There's
Yeah.
a follow-up question to the queens and drones. Do you move the queen only with open larvae? When you say you target capped brood?
Okay. So my queens are reared from eggs on open larvae. So yes, I never will make a divide without providing a source of eggs for the rearing of the queen. But as another important component of those splits, I am putting as much capped brood into those splits as I can to get as much capped brood out of the parent colony as I can.
Okay. And a follow-up question to your winter losses. We had a speaker here last year who did some studies on fluctuations of winter losses and mites and things like that. And she said, do your winter losses fluctuate between higher and lower every other year?
I know where she's getting with that. That there does seem to be like a little bit of a phenomena in the industry. People who are paying attention are seeing this phenomena where a virulent line of mites will develop and come through the country and wipe out a ton of bees. But then in doing so, a lot of those mites get wiped out as well. So then the less virulent lines of mites are left behind as more prevalent in hives that weren't destroyed. So then the following year's mite epidemic are mites that are less virulent. And so honestly, I don't know that I experienced that in our operation. And I think that it's sort of fascinating for me where we're at in the industry, which is that when Joy and I started keeping bees 23 years ago, we quickly got into a pattern where our losses were about 35 to 40% a year. And I remember all of the conventional beekeepers who we were talking with just couldn't believe that we sustained losses like that and that we would do it and put up with that and continue doing what we're doing. And what I find sort of humorous is that the industry has joined us with those loss rates, and yet are clinging to their methodologies, I might add, and yet the industry is having these really unprecedented high loss rates right now, and my operation is doing better than ever. So we're like under 20%. I don't even know how low we are, again 2 times in a row this past couple of years, and I don't really know. We'll see. But I honestly, I'm not going to say it's my management, but I also think it's my forage. We make sure our bees are on really good forage, so we don't feed crappy ingredients to our bees. We make sure they're on good forage. We make sure our yards have adequate stocking rates so that the bees can store away appropriate nutrition for the following spring. We're doing a style of beekeeping that a lot of commercial beekeepers just sort of ignore these days. So
Good job. Anybody else?
You heard of using maxi pads instead of sponges?
I do know people that use those, and I've heard a little bit of varying reports on people's enjoyment of them. Of course, they're quite a bit cheaper. But I've had people tell me they did not enjoy the way they handled in the hive, that they were messy, that they didn't seem to, I don't know, just some variation. And then, I think there's a little bit of variation that people are reporting in terms of effectiveness. While they performed pretty well in Randy Oliver's experiment, they performed second to the cellulose sponge. So I'm just like, you know what? Like $1 per hive plus 10 cents of oxalic acid. I'm gonna stick with that.
Any other questions? You good? All right. Well, thank you so much. That was a wonderful presentation.
You're very welcome. I see here someone really quick in the chat just asked if Joy has scobies for making Jun, and the answer to that is sometimes she does. And if anyone wants to reach us, there is a link on our website, digginlivin.com, that you can reach out to us over questions, and we're pretty good at getting back to you.
Wonderful. Thank you.
Thank you all so much.
Oh, another question is, do you sell and ship your queens?
So I don't sell queens because I don't cage queens. That's sort of another thing about what we do. We don't use queen cages, and we don't ever separate a queen from her sisters who reared her. And so the only way to get germplasm from our operation is we sell starter colonies in the spring, and we do them only by pickup. So that might be a heck of a commute from Utah.
Not gonna do it.
All right. Thank you very much.
Lastly, I will say if anyone was really interested in queens from our operation, the Operation Old Soul apiaries, you can find them. That's OLDSOL. They are a queen breeding operation in Southern Oregon that does occasionally graft from our bees, which is ironic because I think you remember they were a big source of the genetics in our operation. But since we closed the doors on new influx, then, John does take some bees, from our operation and graft them. If someone was interested in queens from our operation, they could maybe make a request of Old Soul.
Okay.
Yep.
All right,
Okay, thank you all.
all right, thank you.
Yeah.